So initial problem, right here, the tangent problem. What does that mean? Back in the old days, let's say grade 7, grade 8, possibly grade 9, we were told that a line is called a tangent line if it intersects, let's say, this circle right here, if it intersects the circle at only one point, just one point. It's like a touch and moves away. It's coming away from the circle, touches the circle, and boom, it moves away. This seemed like a very nice definition. We were comfortable with it. We accepted it. And I don't think that we questioned that definition much. But as soon as you change the circular shape of the object, let's say as soon as you go to something that is more intricate, like this curve right here, I don't think that the definition that we had, that we were given in grade 8, grade 9, may be good enough. For example, again, let's stick to the definition that we were given there. A tangent line is a line that intersects, let's say, the circle at one point. Now we don't have a circle, we have a curve. And if we keep that definition, I want you to look at the red line. It seems as if the red line is a tangent line, right? It's a tangent line at point P. If you notice, at point P, it is somehow just touching the graph at that point and immediately moves away from the curve. But if you now continue the track of the line intersects the curve at another point C. But then we were told in the old days that a tangent line should only touch the graph at one point. So how can it be that it touches the graph at two different points? Yes, it seems to be tangent at P, but then that means that it's going to be intersecting the graph at this point right here. So obviously something is wrong. Now I want you to look over here at the blue graph. The blue graph is intersecting, or the blue line, I should say, is intersecting the curve at one point. But it doesn't seem to be tangent. It doesn't seem to have the same feel as this line on the left right here. So the scenarios that are presented in this curve clearly is telling us that our initial definition of a tangent line was not an accurate definition. It was something that was given to us back then to kind of get us through, to kind of give us a sense of a tangent line, but it's not a proper definition. And it was not a proper definition, because you're going to see in chapter 3 that a proper definition of a tangent line requires sophisticated tools like the ones that you're going to learn in calculus. So a proper definition of a tangent line seriously requires calculus. We need a definition that is not just based on description. Just saying that a line is tangent to a graph if it intersects the graph at one point, that's not enough. One point, that means that that's all that we get on that line, one point. Let's pretend that this point has coordinates a comma f of a, right? Your x value and your y value. Well, if all that we have is one point on this line, we can't even calculate the slope of a line, because to calculate the slope of a line, we need 2 points on that line, not just one. So how on earth do we calculate the slope of a tangent line if all that we have is 1 point on the line? So then obviously something else, something more fundamental is missing here, because we have a definition that is not even allowing us to find the slope of that line. So this definition is still not a good definition. It's not accurate. We're not there yet. That's why we need calculus for that.